Alright, we're going to do lesson 55, circular permutations and distinguishable permutations. This is a pretty easy lesson, so that's good news for you, and it's a little break from some of the other things we've been doing. So remember, permutation is the order of distinct items. So if we did the permutation of the letters A, B, C, the way we can order them is we could do A, B, C, A, C, B, C, A, B, C, B, A, B, A, C, B, C, A. And we've learned that we don't have to write all the combinations, because if we had 6 different letters, it would take us a while to come up with all the combinations. So we learned that if we have a linear permutation, it's just the number of items factorial. So this one would be 3 factorial, which is 3 times 2, so it would be 6. Now, if we're talking circular permutations, they're going to go around in a circle. And instead of doing the little boxes like your book does, we're just going to skip that because it didn't make any sense to me. But if we're thinking of the different ways we can arrange these letters in a circle, there's only 2 ways we can do it. We can do A, B, C, where A is between B and C, or we can do A, C, B, where A is between C and B. There's no other ways that you can arrange these letters. So there's only 2 possible ways that we can arrange 3 letters around the circle. Now again, we don't want to be writing circles with lots of different points and trying to rearrange them, so we have a formula. A formula for circular permutations is just the number of distinct objects minus 1 factorial. So in this case, we have 3 distinct letters. We would subtract 1, and that would be factorial. So it would be 2 factorial, which is just 2 times 1, and you can see we're going to get 2. So this is strictly following a formula that hopefully it's not hard to memorize. So here's 2 quick examples. How many different ways can 6 items be arranged in a line? How many ways can 6 different items be arranged in a circle? So we know if it's in a line, it's just going to be 6 factorial. Just put that in your calculator. 6 factorial is 720. How many ways can 6 different items be arranged in a circle? That's just going to be 6 minus 1. There's going to be less combinations. So that would be 5 factorial, which is 120. Easy as that. Let's do one more. When the chips were down, Ed found that there were 5 chips, and each one was a different color. So we have our 5 distinct items. How many ways could Ed place them in a row? Well, putting 5 items in a row, the different combinations would just be 5 factorial. And that's 120 linear permutations. In a circle, you just take 1 away, and then you do your factorial. So it would be 4 factorial, and that would be only 24 circular permutations. That's it, strictly formula. Let's go on to the next part of this lesson, which is distinguishable permutations. So say we have the word mu, and you can see mu has 2 O's, and if we're going to figure out all the different combinations, we could give the O's subscripts. So O sub 1 and O sub 2. And then with 3 letters, so as we know, we're going to have 6 different combinations. Now if you notice, the 2 O's are the same, so really this would be the same. So instead we would really have 3 different combinations, considering that the letters are really the same. They don't have subscripts. So again, this is a real easy formula. If you're going to figure out the number of distinguishable permutations, it's just the number of letters or objects, factorial. So there's 3 letters, and we would have how many. The bottom line is just how many repeats. So we have our O repeats. There's 2 of them, so it would just be 2 factorial. So the formula is just the total number over the numbers that repeat. So, you know, we've done this before. 3 times 2 times 1, 2 times 1, so these cross out. So our answer would simply be 3, and that's what we found. Now sometimes you're going to have more than 1 letter that repeats. So if we had something like, I can't even think of a word that repeats, Mississippi. If we had Mississippi, M-I-S-S-I-S-S-I-P-P-I, and we wanted to find the number of distinguishable permutations, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 letters. And then we have our repeating ones. We have our S's. So that would be 4 factorial. Our P's, that would be over 2 factorial. And we have our I's, 2, 3, 4 factorial. That one was interesting. So our different combinations would be 11 factorial over 4 factorial times 2 factorial times 4 factorial. We'll do some examples now and get actual answers. So JoJo has 10 marbles, 3 are red, 3 are blue, and 4 are green. So how many marbles do we have? We have 6 plus 4, so that would be 10 factorial. We have repeating. We have 3 red, 3 blue, and 4 green. You could either do straight out do this on your calculator, or you could do it like we did before, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, over, I'll just do this first one out longhand, 3 times 2 times 1, times 3 times 2 times 1, times 4 times 3 times 2 times 1. And of course we can cross out the like ones, so we have, this would cross out the 6, and let's see, this could cross out with the 9, this could cross out with the 8, and so we would just multiply across the top. 4 times 3 times, this should have been 4. 3 times 4 times 7 times 5 would give us 4,200 different combinations. And the last there's another one. How many distinguishable permutations can be formed from the letters in the word nonsense? So we count the number of letters, 1, 2, 3, 4, 5, 6, 7, 8. And we have our repeating. We have 2 n's, 3 n's, so that would be 3 factorial. 1, 2, 3. We have 2 s's, and it looks like we have 2 e's. And then we would just either use the methods I used previously or just put in your calculator, and we get 1,680 different combinations. And our final one, how many distinguishable 7-digit numbers can be formed from these digits? So 7 numbers, so it would be 7 factorial. These are distinguishable 7-digit numbers. We're going to have, oops, my pen stopped working. Hold on a second. Okay. So we have 1, 2, 3, 4 2s, so it would be 4 factorial. And we have 2 4s, so 2 factorial. And if we put that in our calculators, we get 1,105. So these are distinguishable permutations. So that's it for lesson 55.